G'day team, welcome back to another video on integral calculus. Today we're going to look at something called the fundamental theorem of calculus, and what this theorem does is allow us to calculate definite integrals. Now, the theorem itself, for a function f of x with an antiderivative capital F of x, the integral from a to b, so we're bringing those limits back in, of f of x dx equals our antiderivative capital F of x evaluated at b and a. Now the way we do this is substitute b into this function, like so, and subtract what I do when I put a into that function, so substituting a. Now, looks a bit weird, but once I go through an example, you'll see how simple it is and pretty nice to calculate. So just a few properties before we get stuck into it. The integral from a to b of f of x dx equals negative the integral from b to a of f of x dx. So I can flip over our limits or our constraints, but I have to take the negative of my integral. I also have my typical k at the front. We saw that in the last video, so that stays the same. The constant inside multiplied can be brought out the front. If I have the integral from a to b of f of x dx plus the integral from b to c of f of x dx, with c being bigger than b, well, all I can do is just go from a to c. Okay, so I can skip that middle part b because those limits are the same. Means there's no bits missing in my function when I do this for the area. The final one I want to look at and show you again, like in the last video, if I have two functions inside my integral added together, I can split them up and calculate them individually just to make life a bit easier if needed. So they're our key properties and we can utilize them within our questions. So let's have a look at two examples here of evaluate the following. So the first one, I want to integrate from 1 to 4 of x take 3 over root x dx. Now, in this case, this root x on the bottom is a bit of a problem. Can't integrate it as it is, so let's first bring that to the top with a negative indice, so minus 3x to the negative a half dx. So the way I set it up, before we were just writing equals, doing our integral. What we're going to do now is when we actually calculate the integral, we're going to put it in this square bracket that we saw above. Now x becomes a half x squared. So I raise the power by 1, divide by the new power. Now, if I add 1 to this power, I've got negative 3x to the 1 over 2 divided by 1 over 2. And that is from 4 to 1. Now, what I can do in here is simplify this. If I divide by a half, it's like timesing by the flip of that or the reciprocal of that fraction. So this becomes 3 times 2, which is 6. Now, the other thing to make our life a bit easier, I've got to the power of a half here, which we know is the square root of x. So you can make it, we'll put it back into a form that's a bit simpler for you to calculate. So let's now have a look at what happens when I evaluate this. So 4 is acting as my b value. So I substitute that into my integral first. So 1/2 times 4 squared, take 6 times the square root of 4. Now I'm going to subtract, I'm going to put it in a bracket because there's multiple terms. So now I put 1 into my function. So I've got 1/2 times 1 squared minus 6 times the square root of 1. Okay? And you can see that these are just numbers. You could plug this into your calculator. I'm going to just do it by hand, and we're going to do it bit by bit. So 4 squared is 16, divided by 2 is 8. 6 times 2 is 12. Minus, I've got a half. Minus and minus is plus, so plus 6. Now 8 take 12 is negative 4, plus 6 is 2. 2 take a half is 1.5, which is 3 over 2. So we've finally got our result. So the integral from 1 to 4 of x take 3 on root x is just 3 over 2. Let's have a look at one more example over here. So I've got sine of 6x. So we saw in the last video that sine goes to negative cos. Is integrate this, so we've got our square bracket, negative cos of 6x. However, I have to divide by the thing in front of the x, which is 6. I'm going to evaluate that at pi over 2 and pi over 3. So let's substitute pi over 2 into our function. Negative 1 over 6 cos. Now 6 times pi over 2 is actually just, 3 pi minus 1 over 6, so plus 1 over 6 cos. Pi over 3 is going to be 2 pi. Okay, so 6 pi divided by 3 is just 2 pi. Now, cos of 3 pi is negative 1, so this becomes 1 over 6. Cos of 2 pi is positive 1 plus 1 over 6, which is 2 over 6 or 1 over 3. And we have done it. Cool. What will happen though is a trickier question you'll find in the exam or on a test will incorporate unknowns in our limit. And we can utilize our integration properties and our fundamental theorem of calculus to actually find this a value. Now we're going to find the exact value of a. Typically when they ask you for that, it's going to be in terms of natural log, exponent or exponential functions, e, or sine and cos. So we're not finding the actual value, we're just finding the exact value in terms of those things. So let's have a look at this question. So we want the integral from 0 to a of e to the power 1 take 2x dx equals e over 4. So we know what the fundamental theorem of calculus is going to give us. It's going to give us e over 4. So now we can find this a value. So first of all, let's integrate our function. So we write the same exponential and we divide by the thing in front of x, which is negative 2. Now this is evaluated at a and 0, and we know it's equal to e over 4. So let's substitute a into this function. Negative 1 over 2 e to the 1 take 2a minus, but it's going to be a plus because I've got a half, negative a half, 1 over 2 e to the power of 1, because negative 2 times 0 is 0, to the power of 1 equals e over 4. So let's now start manipulating this expression so we can get a by itself. So the first thing I'm going to do is times by negative a half. So that gives me e to the 1 take 2a minus, well, I'm actually going to times by 2, negative 2, to get that off the bottom, not negative a half, make it even more of a fraction. So that's going to give me negative e equals negative e on 2. So we've started to simplify it. Now I'm going to add e to both sides. So I've got negative a half e plus 1e is going to give me just a half e. So I've got e 1 take 2a equals 1 half e. Now I've got a by itself in a single term on this side. I can take the natural log of both sides as such. So on the left hand side I'm left with 1 take 2a, and on the right hand side the natural log of a half e. We'll roll up here. I'm going to subtract 1. Negative 2a equals the natural log of a half e minus 1. Divide by negative 2. A equals 1 take the natural log of a half e. That accounts for the negative divided by 2. Now that is the exact upper limit that would give you the solution e over 4. So it can get a bit complicated, but just follow your log laws and you'll be fine. Thank you very much for watching, and I'll see you in the next video.